This is a simple overview of some of the systems in use during the flight of an aircraft, presented from a dynamics and controls perspective.
Flight dynamics consists of vehicle orientation and controls in 3 dimensions, but first it is important to understand the forces applied to a plane that allow it to fly. The main two forces include lift, upward forces created by the wings, and drag, the resistance that an aircraft experiences from its environment. Weight applies a downward force on the aircraft due to gravity, which has a careful relationship with thrust, where each affects the balance and propulsion of the aircraft. One example of actuation may occur when an aircraft experiences crosswind. Crosswinds define a perpendicular force from the direction of travel caused by wind. The aircraft directly experiences this perpendicular force and will begin drifting. To counteract, an aircraft can rotate along its z-axis to point against the direction of the wind, eliminating the perpendicular force.
Dynamics of rotational movement. The aircraft is bound to 3 different dimensions of rotation: yaw, pitch, and roll. If we base our coordinate system on the picture shown below, then the yaw rotation occurs about the z-axis, the pitch rotation occurs about the y-axis, and the roll rotation occurs about the x-axis. Each one is made possible by a separate individual actuator. Rudder is responsible for yaw, ailerons control the roll, and the elevator makes the plane change its pitch.
Many modern aircraft and drones use feedback loops to automatically operate these flight control surfaces. For example, the pilot can specify desired altitude, bearing, or bank angle for the aircraft. With the help of sensors on board the aircraft, a computer can calculate the error or difference between the desired state of the aircraft and its present state. With that information, the computer can automatically operate the flight controls to achieve and maintain the desired state. If the pilot wants a steady and level flight, the autopilot will use feedback loops with a PID controller to control the ailerons automatically without user input to level out the aircraft.
The inertial frame of an aircraft is a body fixed frame that has a z-axis that points down to the center of the earth, an x-axis that comes out the nose, and a y-axis that goes along the wing of the aircraft. This frame can be compared to another frame so that we can analyze the dynamics of the aircraft, such as the ECEF frame, which is the Earth-centered, Earth-fixed frame that rotates with the Earth, or a local geographic frame, which is tailored to a specific point on the Earth, such as an airport. Here is a schematic block diagram of an aircraft that shows how the systems of an aircraft work. And in conclusion, this is how the dynamics and controls of an aircraft work.